Today is November 13th, 2024. Nobody is coming yet, but I will start very quickly because I don't have time right now. Java data structure test is what I'm going to talk about. First, when you talk about data structure, you need to discuss about time complexity. If you go time complexity deeper, then it's kind of annoying, and you can even write paper for our goal. Very simple. This is Tn. We so-called it growth function. So let's think of the examples 1 to 3. If we can find polynomials like n squares over 2 in Tn, then if you go to On, which is asymptotic functions, we can easily find if it is n squared or it is n. Or how can we distinguish it? Let's think about for loop. For loop is the most easiest part. And if you go to recursive, it's kind of recursive and iterative. You should think some things a lot. In recursive case, like such as when you call this function once again, let's say xn, then you will call another function. When you call another function in only one branch, and because of this call, the whole operation that we need to do actually goes to half of it, then we can say this is log n algorithm. Then for loop, there will be I will get bigger to n, I plus, then it will be n. And if it is I over 2, plus, then it will be log n. And if it is not, and if it is independent to n, let's say k, or I just goes to 3, then it will be not effective to complexity. If we have 2 for loop, then it will be n multiple n, and there is another log n, then it will be n multiple log n. This is how it works. If you go more advanced, maybe there can be such complexity, maybe n squares and double squares multiple 2.45, or let's say A and B is equivalent, then we will find problem A and problem B's time complexity, and we will check if it is NP problem. I will not go deeper. In complexity, there will be 3 indexes that you can use: On and zeta and there will be omega n. There will be 3 notation for the complexity. And when you think about stack algorithm, or anything stack algorithm or linked list, double linked list, we should think about first ADT of data structure. Let's say stack, then we should think about push and pop, pick, and is empty. And maybe clear function, we can implement it for it. Maybe push for void class, and pop for maybe P. Generic T, we can use generic T, maybe public. We can use T, generic T to implement pop functions. And maybe we can use take method, we can use same t and it's empty. So you should think about how many methods you should implement for each data structure. This is what you need to do in ADT. And when you implement it, you can, for example, push. Let's say when you check the size, you can use pick method. It will be also, they will have same complexity even it is pick. So you just pick the top one, or you just pick the, you just return the size, it will be same. And when you implement is empty, you can use various method. Maybe you can implement it in return size equals to 0 by checking it is, then the class will be Boolean. And second case, it will be also Boolean, but you can check if type equals to null. If it is, then it will return 1, and if not, it will return 0. And you should also very carefully distinguish between recursive and iterative. The complexity will be different, and there's a lot of terminology about tree from node, edge, level, root, parent, children, ancestor, descendant, subtree, degree, leaf, interior node. Interior node is node which is not a leaf node. Except a leaf node, everything will be interior node, and there will be path, height, depth, full tree, and size. Especially when you consider depth and height, sometimes you consider from 0 and sometimes you consider from 1. So you should carefully distinguish it. Let's see, 3. This will be 0, 1, 2, 3. Then the level, it will be level. There will be sub-tree, which will be any node, and it's descendant from sub-tree or original tree or tree rooted as a child of that node. And there's also definition of full tree. Full tree is a tree is full, literally, if all of its leaves are at the same level and all of its other nodes have the same degree. And there's a very important thing that I forgot the name, but every tree can be switched, is able to change to binary tree. If we apply some rules, we will discuss it later. Today it is simple overview. And another important thing is how will you traversal? There can be BFS and there will be DFS. DFS, there can be 3 cases, which will be pre-order, in-order, post-order. I will go very quick. Let's say 1, 3, 5, 7, 9. If we, and let's make another example, 5, 7, 9. Then if you do it in pre-order will be node left, right, it will be sequence. So let's say node pre-order, a node will be 5, and you will go to left, then 5, 3, and you will go to left again because you did node left, right, you should apply to each node. In this case, then it's recursively called 1 and left, right, there's no right, so you will go up. Then there's 7, then you will read 7 and 9. Pre-order case. Let's see pre-order case. This will be in-order case. If you go to pre-order case, then remember it is node left, right. Then you will print. Yeah, this is pre-order. In order, And in order case, think about in order, then it would be left node, right? But then let's go to left. And there's another left. Then you refer from 1, 3, left, go up, 3, 5, 7, 9. We can maybe also implement this, how it is work recursively. Oh, will be also very important thing. In the expression tree, there is operand and there's operator. We can match in order with infix and pre-order with prefix and post order with postfix. I hope you try this. I talk about ADT when you implement the data structure. You should also think about interface, how it looks like. And there will be UML class diagram that you will make. And there is in class linked tree, and there is inner class tree node. And Hanoi Tower will be in binary search method. Its complexity is theta n or n squared. Please figure it out next time. And in this case, if I do it right now, post order will be LRRR node, LRRR 97531, and pre-order, no, in order case. So pre and in order will be, I guess, pre-order will be node, left, right, node, use. Okay, node case 1, 3, 5, 7, 9, and a pre-order case 1, 3, 5, 7, 9, and in order case left, there's node, 1, 3, 5, 7, 9, pre-order, node, left, right, node, 1, 3, 5, 7, 9. So in this case, probably pre-order and in-order will be seen. And today's problem, I very simply explain it quickly, and it was there is heap, which is one type of tree. There will be heap, which is min, and there will be max min. Min heap will be tree is the smallest. The first node will be smallest, and it will get bigger. And max min will be the biggest, and it will be smaller. Index, how we give index, it will be let's say we will input it in list. There will be just and first one, second one. Then we can give index by, let's say it's first one. Then it will be 2 multiple like first index plus 2, and it will be 2 multiply plus 1. We can give index like this. And there will be AVL tree and red-black tree, which is self-balancing tree. There will be different mechanism of indexing and how they organize their self. Still, there's no one came out, but I will briefly finish my overview and see you next time.